Separation procedures and techniques. Filtration separates a solid from the liquid in a heterogeneous mixture. Filtration is the method of choice to remove solid impurities or components from a liquid. It can be performed by applying a vacuum as well to speed up the filtration. Filtration involves pouring a mixture through a specially folded filtration paper supported on a funnel and letting gravity pull the liquid through the small pores in the paper, just like a coffee filter. Chromatography is the technique of separating chemical mixtures into individual components. The mixture is first dissolved in a fluid called the mobile phase. The mobile phase is then allowed to pass through a stationary phase. The various parts of the mixture travel at different speeds through the stationary phase, causing them to separate. Chromatography separates components of a solution based on their unique physical characteristics. Molecules vary in polarity, size, and binding affinity. Any of these characteristics can be used to separate molecules into different fractions using different chromatographic techniques. The best technique for each separation problem depends on the types of molecules in the solution. Chromatography may be used to identify or quantify the molecules in a solution. It can also be used to purify the components of a solution. Two types of chromatography will be discussed here. In paper chromatography, the stationary phase is a strip of paper, shown here and also on this picture over here. Capillary action draws the mobile phase up through the paper with different components of the fluid traveling at different rates, which means they're separating. Each component is revealed by its color appearing at a different height. Column chromatography is a general term. It refers to using a glass or metal cylinder to hold a stationary phase in place. That's called the column, while a complex liquid or gas sample moves through it and gets separated into its components. The column matrix is chosen to separate molecules on the basis of size, polarity, or affinity for the matrix, whichever quality is best for the sample mixture. As a sample moves through the column, and here you have a sample, and we're representing the different molecules by their colors there and sizes. Different components of the sample are slowed down to different degrees depending on their physical properties. So they're moving down like this, and hopefully you can see the red is at the bottom, green here, and blue is moving the slowest. Individual fractions are removed from the end of the column, down here, drop by drop, and contain molecules that are separated from the mixture based on their characteristics. Distillation is the process of separating a liquid mixture into its component parts. It can separate liquids from non-volatile solids or separate the liquids that comprise a mixture. The liquid is slowly heated until it reaches the boiling point of one of its components. As that component boils, its vapor is collected and condensed back into a liquid. But now that liquid is comprised of just that single component of the original mixture. The process is continued until each component is collected, separating the original mixture into pure samples. So here we have our original fluid, and that's in the distilling flask. It's heated with the Bunsen burner. You have a liquid evaporating like this, and then it's cooled in the condenser. You have cool water in here. It flows through, comes out this way. Now this water is not connected to the gas that is condensing here. They're separate. And then finally, the gas turns back into a liquid, and it's collected over here, and it's called the distillate. The receiving flask can be connected to a vacuum to support a lower boiling point to avoid decomposition of the mixtures if necessary. Gravimetric analysis determines the mass of a solid substance produced, usually by mixing two liquids or aqueous solutions. Precipitation gravimetry uses a precipitation reaction to separate one of the products. The solid product will be filtered using quantitative filter paper, washed and then dried. The mass of the solid recovered will be used to calculate the percent yield using stoichiometry of the reaction. The recovered solid product, which is up here in the filter paper, can be ignited along with the filter paper to convert to a stable oxide or sulfate to make a quantitative analysis. And it'll fall down here. You can see we have a vacuum here helping it fall. The special filter paper will burn off without any residues. Decantation. Decantation can be used to separate a liquid and solid mixture or a mixture of two immiscible liquids. What is immiscible? Well, that's liquids that will not blend together, like oil and water, that have different densities. For liquid and solid mixtures, the liquid can be poured off the top. For liquid and liquid mixtures, it is best to allow the more dense liquid to drain out of the bottom using a separatory funnel. Decantation is necessary in the production of biodiesel. Glycerol is formed as a byproduct during the process. Since glycerol is more dense than the biodiesel, it can be separated through decantation. The processing of crude oil can involve decantation to remove impurities such as mercury. Mercury, a dense liquid, can be found in high levels in crude oil. The mercury poses several problems during crude oil refinement. The presence of mercury generates toxic waste, damages equipment, destroys catalysts, and presents serious health impacts. And out of something a little more peaceful, cream is obtained through the process of decantation. After centrifugation, which we'll talk about shortly, the less dense cream floats on top of the skimmed milk. Centrifugations. Another way to separate mixtures is with a centrifuge, and that's over here. A centrifuge is usually driven by an electric motor moving in a rotational motion. Samples, hopefully you can see them here, are spun until a centrifugal force pushes the more dense substance to the bottom of a tube. Centrifugation can be used to separate skim milk from whole, blood cells from plasma, uranium-238 from uranium-235, and even to separate your clothes from water. Pelleting happens when particles are concentrated at the bottom of the tube. The liquid above the pellet, called the supernatant, is often used in industry for a variety of purposes. Crystallization is a process in which a chemical is converted from a liquid solution to a solid with highly organized particles. There are three different ways to accomplish this: evaporation, cooling, and precipitation. Filtration or decantation might be necessary to complete the separation. In the first step of the crystallization process, an impure solid is dissolved into a solvent. Next, step 2, the solution is heated to evaporate much of the solvent. This helps to speed up the process. As the hot solution cools, notice there's no Bunsen burner there anymore, crystals begin to form. Finally, the cold solution is poured off. So here we're allowing the solution to cool. The solid starts appearing as these crystals. Pour off the cold solution, and we're left off with the crystals on top of the filter paper, and they can be dried by pressing them between separate sheets of filter paper. Crystallization by means of evaporation begins with a supersaturated solution. This solution is allowed to evaporate, leaving behind crystals. Supersaturated saline solutions are often evaporated to mine crystallized salt. In some places, like the Bonneville Salt Flats in Utah, vast expanses of crystallized salt are formed by evaporation. In some cases, crystals are precipitated by seeding a supersaturated solution. Making rock candy is an example of crystallization using precipitation. During this process, a string or a wooden stick, there's the wooden stick there, is placed into a supersaturated sugar solution. Sugar molecules stick to the string or the wooden stick, and these initial molecules act as a seed for larger crystals to grow upon. Crystallization is used as a step in many industrial processes that require purifying a solid. Salt is commonly produced through the process of crystallization. Ice cream gets its consistency by making use of crystallization. And finally, honey is also formed from the process of crystallization. Honey starts as a liquid when bees first regurgitate it. Sugar then forms crystals over time. Titration is a technique to determine the concentration of an unknown solution. It is a quantitative process of adding a known quantity of a liquid aqueous solution, called the titrant, to a measured sample, called the analyte, to react in a definite known proportion. The addition of the substance is stopped when the equivalence point is reached. That is determined by a color change when a point is reached when one reactant is fully consumed. Titration will be covered in much more detail in the pH and titration unit of this course. Calorimetry. A calorimeter is a device used to measure the temperature change during a chemical reaction or process. This device allows chemists to study the heat flow of a reaction. Over here, we have a coffee cup calorimeter. It's an insulated cup, like a coffee cup, that's where the name comes from, fitted with an insulated lid that can accommodate a thermometer, a stirrer, as shown in the diagram. The materials, usually substances dissolved in water, are placed inside the cup. The mass of the contents, the initial temperature, and final temperature are measured. From these parameters, the heat flow of the process can be calculated. This is covered in much more detail in the thermochemistry unit in this course. When a reaction produces a gas, that's what's going on here, and the collection of that gas is vital to the study of the reaction, the gas can be collected over water. See the gas coming over like this, in here, and it bubbles up. Collecting gas over water is accomplished by inverting a piece of glassware, here's your graduated cylinder, and a tub of water. And you can see the gas bubbles up here. The gas, along with a small amount of water vapor, will displace an amount of water equal to the volume of the gas. The amount of water vapor will need to be subtracted from the total volume. The volume of gas collected, the room temperature, and the barometric pressure on the day that the experiment is performed are recorded. Using the temperature, the amount of water vapor can be found in a table. Once the water vapor has been subtracted from the total gas collected, the amount of gas produced in the reaction or process can be used for further calculations. A spectrophotometer can be used to find the concentrations, how much of a chemical is dissolved in water, of colored solutions. It works by measuring the amount of light that is absorbed by the solution. Spectrophotometers need to be calibrated before each use. Since litmus paper only indicates that a solution is acidic or basic, a pH meter is used when it is important to know an exact pH of a solution. The probe, over here, is rinsed with distilled water, gently shook until the excess water is removed, and then placed in the solution until a stable reading is achieved. pH meters, like spectrophotometers, need to be calibrated before each use.